In this work, we present Cascaded Compositional Residual Learning for complex interactive behaviors. The core idea of CCRL is to avoid training new skills from scratch, but instead train them as constrained residual perturbations to a combination of pre-learned skills. For example, by perturbing a trained joint level walking policy systematically, we can get the robot to turn left. These learned residual policies can in turn be used to train more complex skills. This process is repeated to recursively build a library that follows an underlying skill dependency graph structure. To combine the outputs from multiple parent skills and residuals, we use a multiplicative compositional policy framework that enables us to merge a large number of skills together to create complex interactive behaviors. First, we start with a straight walking policy that is trained from scratch using RL and ensure that we can transfer it reliably to the real world. By perturbing the walking policy, we then teach the robot to turn. By testing each intermediate skill, we ensure that we have successful sim-to-real transfer. Next, we train the robot to open a door. The robot is penalized if its body touches the door and is rewarded for walking forward and pushing the door open. In the real world, we track the state of the robot and the door by using mocap markers. While navigating in indoor environments, the robot might need to traverse narrow spaces like crawling under furniture. We present a crawling policy trained by adding a residual to the walking policy. Next, we build more complex skills using combinations of these learned skills. To reach a target, the robot uses a combination of turning and walking skills, and we transfer it to the real world by adding mocap markers to a sheet of cardboard and making the robot navigate to it. We additionally train a manipulation policy that can push an object to a target location. Finally, we train policies on challenging interactive navigation tasks where the robot must get to a target object placed somewhere in a two-room house. We deploy this policy in a real-world indoor scene. Our robot crawls under a desk, navigates to the door, pushes it open, and then proceeds to reach the target. We compare our approach to multiple traditional baselines. Notice that while simpler tasks like opening a door can be tackled with curriculum learning, our method shows more performance gains on harder tasks such as interactive reach. Our approach reaches a success rate of 72% on a challenging interactive reach task, beating baselines by a large margin. The quality of trajectories generated by our approach is significantly better than baselines as we ground all our skills in a pre-learned skill library with residual penalties. Further, we can control the style of our generated trajectories by tuning the weights on the residual penalties. To summarize, we proposed Cascaded Compositional Residual Learning, a technique to build interactive behaviors by recursively leveraging a library of pre-learned skills and task-specific residuals. We use this framework to achieve high success rate in a challenging interactive navigation task. Please check out our paper for more details. Thank you.